Okay, today's lesson is 3.3, Graphing and Solving Systems of Linear Inequalities. The learning goal, to graph a system of linear inequalities to find the solutions of the system. Okay, definition of a solution of a system of linear inequalities is an ordered pair that is a solution of each of the inequalities in the system. Now, our systems are going to have 2 and 3 inequalities in them, so the solution has to make each of them true, and more specifically, the solution or the ordered pair has to be located in the shaded area for each one. Okay, well, let's take a look at example 1. We're given a system down here, and we're going to graph this. So step 1, we learned this in an earlier lesson, I believe 2.6. We learned how to graph linear inequalities. But the first step is to take the linear inequality and write the equation of the boundary line. So I'm going to take the first one, and the equation of the boundary line for that one is going to be y equals negative 3x minus 1. And the second one, put in slope-intercept. It's already in slope-intercept form, but making the boundary equation of the boundary line, it's going to be y equals x plus 2. Okay, so we'll proceed to graph this one. Okay, so this one crosses the x-axis at -1, and then we follow the slope. Well, the slope's got to be a fraction, so if it's not, I just put it over 1. It tells me to go down 3 and to the right 1. Okay, the next step is to look at your original problem and decide whether or not you're to draw a solid line or a dotted line. Now, if it has the or equals, it's a solid line, and if it doesn't have the or equals, it's a dotted line. So we're going to draw a dotted line through these 2 points. And if you followed some of these other videos that I've done, I finally figured out how to draw a dotted line. How about that? I hear the cheers already in the background. Okay, and then the second one, this one's going to cross at +2, and the slope on this one, well, I don't see a number, but there's a number there. It's 1 over 1 to go up 1 and to the right 1 from our y-intercept, and this one is also a dotted line, so we'll pick up our dotted line and draw a line through these two. I really like this software. I'm getting used to it. Okay, now the shading. All right, so with this one, we want to pick a trial point, and we always want to pick 0, 0 if it's possible, because it makes the math so easy, and 0, 0 is a point off of this dotted line, so 0, 0 can be a test point for this inequality. So I come back up to the inequality and plug in 0, 0 to this first equation. Well, that would be 0. And let's think this through. Negative 3 times 0 is 0, and then 0 minus 1 would be -1. Now, if this is a true statement, then the origin is on the side that we shade, and if it's false, it's not. Well, 0 is greater than -1. This is a true statement. So it tells me that the origin is on the correct side of this dotted line. So I'll come down here and I'll make some orthogonal lines to indicate that this area is the solution to the first one. All of this. Okay? All right, the second one, the origin is a possibility because it's a point off of the line. So we plug 0, 0 into this second one, and we get 0 is less than 0 plus 2 is 2. Is 0 less than 2? Yes, it is. That's true. So it's also this is the side that we need to shade for the second one. So we shade toward the origin on this one. Okay. Now, when we talk about the solution to the system, it's all the points that will solve both of them, or it's the overlap of the two solution sets. So if you can see that this double shaded area right here, I'm going to go ahead and highlight it with blue. So it's going to be all the points that got in the double shaded area. So we'll do something. Forgive me for going over that line right there. It's going to be all the points in this area. So we found the double shaded area. Double shaded because there's how many inequalities in this system? There's 2. So any point that fell in this region is part of both solution sets, thereby making it the solution to the system. Okay? All right, let's go ahead and give a try to one for you. I'll go ahead and pause the video and let you guys do this one. All right, we got a little more work to do here because these, after we change the inequality sign to an equal sign, they're not in slope-intercept form, except, well, the first one's not, let's say. So here are the equation of the boundary lines. This one's in slope-intercept form. This one isn't. We have to get it in slope-intercept form, so we subtract x from both sides. And it leaves us with negative 2y on the left-hand side. And putting in the algebra order, the x first, and then 3 is positive, so I'll write plus 3. I'm going to go ahead and put the 1 in front of the x because I'm about to divide both sides by negative 2, and I want to see that fraction. Negative 2 over negative 2 is 1. 1 times y is y. Negative divided by negative is positive, so we get 1/2 x here. And positive divided by negative is negative 3/2. Okay? All right, both of these are ready to graph, so let's go ahead and graph them. So this first one crosses at negative 3/2. That would be like 1.5, or right there. And the slope tells us to go up 1, so halfway between these two, up to the halfway mark is 1. That would be 1 right there, and go over 2. And so this is a point on our line. And we don't have the or equals, so we're still doing dotted lines here. Draw a dotted line through these. All right. And let's do the second one. It crosses at negative 4. The slope is 3 over 1. So from this point, the y-intercept, we go up 3 and over 1. And check our inequality. It is also a dotted line. And the meaning of the dotted line in terms of our solutions is that points on the line will not solve or are not solutions. Okay. And it looks like that 0, 0 is a point off of both of the lines, so I can use that as my test point for both inequalities. So when I put 0 in for x and y here, I get 0 is less than 3, which is true. So the first one, which crossed at negative 3/2, we shade up. And in this one, we put in 0, 0, we get 0 is greater than negative 4. That's also true. So the origin's on the correct side for this one here, so we shade toward the origin. And then we look to find the double shaded area, which is going to be everything inside these two lines right here. From here, and it's going to go down this way. And everything in here. Okay. All right. Let's move on to the next problem. All right, graphing a system. Here's a system with 3. So the procedure is basically the same. We change these, or we write the equation of the boundary line, so it's x equals 0. For this one, it's going to be y equals 0. And for this one, 4x plus 3y equals 12. Well, this one I'll have to put in slope-intercept form to graph, so we subtract 4x from both sides. We get 3y equals negative 4x plus 12. Divide everything by 3 to get y by itself. we get y is equal to negative 4/3 x plus 12 over 3 is 4. Okay, let's start graphing these. This one crosses at positive 4. It goes down 4 and to the right 3. Check the inequality sign. All of these are not going to have the or equals because I didn't have a way of putting or equals in it, the software, or I don't know how to do it yet. So all of these today are going to have dotted lines because I wasn't able to put the or equals sign in there. All right, so there's that one. Okay. Now these two, I don't know what happened to my equal sign there. It didn't take, obviously. Okay, these two are lines that we should just know where to put them. X equals a number is a vertical line, and y equals some number without the x is a horizontal line. But x equals 0, well, that's a vertical line through the origin, and there's already a vertical line through the origin. That's the y-axis. So I'll just kind of come over here and highlight the y-axis again. Okay, maybe you can see that. And x equals 0 is that is the y-axis. Y equals 0 is the x-axis. So let's put us a dotted line there. Okay. Now we're going to do trial points. Okay. Now, the origin will work for this line. It's a point off of the line. So we can put the origin in here, and we put 0 in for x and 0 in for y. We get 0 is less than 12. Okay, which is true. So the origin is a solution. And with 3, I start to not shade, but just give arrows. So I'm going to indicate that this is the area that should be shaded. And what we'll do when we get through is we'll decide what's triple shaded instead of just shading so many times, so it sort of gets confusing then. All right. Now, for these, I can't use the origin as a test point. Well, my next favorite point is 1, 1. It's easy to plug in. And so we'll plug 1, 1 into this top equation here. Well, it really only requires one of the ones. So we get 1 is greater than 0. And is that a true statement? Yes, it's true. So 1, 1 is a solution for x equals 0. So it tells me that I would need to shade this way. So I'll just put a couple of arrows in here. So at this point, the only part that's double shaded is outlined by my pen right here. It's this triangle right here. Now, the solution to this one, because it has 3 inequalities, has got to be triple shaded. Well, the triple shaded area has to come from the double shaded area. So right now, in my mind, the only part of this graph that matters is inside here, because that's the double shaded area. Okay? Now we'll find the triple shaded area by graphing by doing the test point for this one. If we put 1, 1 in here, we get 1 is greater than 0, and that's true as well. So for this one, we shade toward the 1, 1. Well, we just said that the only part that really mattered was this right here, because that's the double shaded area. Now the triple shaded area, I think you can see, is this triangle right here. So again, we didn't shade all of it. We just sort of put arrows to indicate what part I'll say was still in bounds, and we found that any point in this region here, yes, I liked to color when I was young. Get all the spaces colored in. Okay, that's enough. All right, so this is our triple shaded area. This is the solution set to the system. Okay, go ahead and get you to try this one. All right, that should have been time enough for you to do that. And the equations of the boundary lines: x equals 0, y equals 0, and x minus y equals -2. Putting this one in slope-intercept form, subtract x from both sides. Negative y equals negative x minus 2. Divide everything by -1. And y equals negative over negative is positive x. Negative divided by negative is positive 2. Okay, this one crosses at positive 2. The slope, up 1 over 1. and draw the line. Okay. Okay, these two are two that we have already been used to graphing. X equals 0 and y equals 0 is the x and y axis, so I'll highlight those. Now be careful. Don't always guess the little triangle. It may or may not be the answer. I don't know this time. Let's see. Okay. Trial points. Let's take 0, 0 and plug it into this one. So is 0 minus 0, which is 0, is 0 greater than negative 2? True. This works, so we shade toward the origin, and I'm just going to indicate I've got basically 3 different sections of this line. So I'll indicate on all 3 of them that we're shading, I guess, down and to the right. And let's go back to our old faithful 1, 1 with the x and y axis. Is 1 less than 0? That's false. Well, so for x equals 0, this is the wrong side to shade. We would shade away from the origin. Maybe it's going to be that little triangle. Who knows? Okay, so now the double shaded area is outlined by my pen here. It's this triangular sector right here. All right, we put 1, 1 in here, and we get 1 is greater than 0. And for the y-axis, okay, which is y equals 0 here, it is a solution. So we shade up, and it appears that it's the little triangle again. But if you think it's always going to be that little triangle, you're mistaken. But this time it is. So here's the triple shaded area. Any point from this area will make all 3 of these inequalities true. It is the solution of the system. Okay? All right, next problem. Get you to try this one. Give you a little time. Okay, well, here's the equations of the boundary lines. These are already in slope-intercept form. That's not going to be, so we don't have that work to do. Slopes, let me put them in here. Okay, so from -1, we're going to go up to and over 1 and put in our line. Again, these are all going to be dotted because I didn't have a way of making a less than or equal to sign with this software yet. Something tells me you can do it, but I'm not sure how. And then the next one, this one crosses at +3. Slope is also up to and over 1. Put in our line. Okay. And this one, well, it's ready to graph because x equals 0 is the y-axis. So we'll highlight the y-axis here. And do trial points. Okay. Now, the origin will work for these 2 lines or these 2 equations. So let's put 0 in here. If we get 0 greater than -1, which is true. So for the one that crosses at -1, it is the side we shade. We shade toward the origin. Okay. So both of these sections here would be shaded, or I'll just indicate with an arrow. And we put 0 in here. We get 0 is less than 3, because 2 times 0 is 0 plus 3 is 3, which is also true. So we shade toward the origin on this one. Okay. So now the double shaded area is between these parallel lines. All right. The origin is not a possibility for this one. So I can try 1, 1 in here, and 1 is 1 greater than 0. 1, 1 is the correct side on this one, so everything to the right would be shaded with that one. Now, what area got 3 arrows in it? Okay, that's going to be the triple shaded area, and that's going to be this area right here. There's a little kid in me that wants to color all of it, and I apologize for that. Okay, next problem. Determine, example 3, determine if a given ordered pair is the solution to a system. Well, we've done problems like this before. What you have to do is plug the XY values into both of them, and have to make both of them true. Okay, so this first one, if we put in the 0.14, well, this is only calling for the x, so I'll put the x coordinate 1 in. Is x greater than -1? And that's true. And in this one, I'll put in the x and the y. Is 4 greater than 2 times 1 plus 2? Is 4 greater than 4? Well, 4 is equal to 4, but it's not greater than. So this is false. And so we would say, is this a solution to that system? No, because it has to solve both of them. Okay, you go ahead and do this one with the same system. Okay, well, we put the 2 in for the x, and 2 is greater than -1 is true. We put the 7 in for the y and the 2 in for the x. And is 7 greater than 2 times 2? 4 plus 2, is 7 greater than 6? Yes, it is. It's true. Don't know what happened to my E up here. This one's true. It makes both of them true, so we would say yes, it is a solution to the system. Okay. Next problem. Tell whether the ordered pair 2, 3 is a solution of the system. And this time, instead of giving you the equations, I've given you the graph of this. So what we have to do here is pretty simple. Is we have to locate the point 2, 3, and the point 2, 3, go over 2 and up 3 is this point right here. You have to ask yourself, is this in the solution set? Well, it appears to be right on the line. Now, what's the rule about dotted lines? Do those points, are they included in the shaded area or are they not? Well, it looks like my shaded area might have skipped over into this area, but a dotted line is not part of the shaded area. So the question, is this a solution? The answer would be no. What about this point here? Well, that's right on the edge of the solution area, but it's on a solid line, and solid lines are in the shaded area, so we would say yes to the point 0,4, no to this point. So this answer would be no. Okay, that concludes this video, and thank you for watching and listening, and I'll give the assignment after the video closes.